What's up, y'all? Welcome back. Today we are going to talk about section 3.3. Okay, and this is called polynomial identities. So you see it right here, polynomial identities. All right. This does not come from our book. I don't really like our book notes, so we're going to do some that are a little bit separate. All right. And this is going to be relatively quick. Okay, it's only like a few problems we're going to do. And once you kind of learn the formulas, this is actually pretty easy to do. All right. So the very first thing that I need you to write down is we need to know what our squares are, like what our perfect squares are. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so forth, right? 5 times 5, 6 times 6, 7 times 7, 8 times 8. So these are called perfect squares, all right? And I went all the way up to 12 times 12. All right, if you know up to 12, you're in pretty good shape, all right? Underneath that, these are all perfect cubes. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So these are cubes. So the squares are on top, the cubes are down below. All right. If you know those, it's going to make your life a whole lot easier. Okay. Now you might not get them memorized. You might be able to go up to like 125, like 5 times 5 times 5, and that's okay. You don't have to memorize them. All right. You'll always have a calculator, but if you do know them off the top of your head, it's going to make it go a little bit faster. Okay, so a little while ago, back in topic 2, we discussed difference of squares, right? So whenever both things were squares, like a squared minus b squared, we split it up into a plus b, a minus b. All right, today we're going to talk about what you do when you have sum and difference of cubes. So now we're going to talk about what you would do if you had a cube plus a cube. That might be a little bit hard to see. Let's see if I can make it bigger for you. You have a cube, a cubed plus b cubed, and a cubed minus b cubed. Okay, and these are the two formulas that we are going to use. So these are what you're going to want to make sure that you write down. Okay, so if it is a cubed plus b cubed, that will factor into a plus b, then a squared minus ab plus b squared. If it's a cubed minus b cubed, it's really, really similar, right? You'll notice the only thing that changes is that first plus turned into a minus, and the second minus turned into a plus, okay? So the way that I remember the signs, I remember these signs through something called SOAP, S-O-A-P. The first sign is always the same, okay? Because the first sign, this was a plus, the first sign was a plus. This was a minus, the first sign is a minus. The second sign is always the opposite, right? So look here, the first sign was a plus, the second sign was opposite. The first sign was minus, the second sign, okay? So opposite. The third one is, the third and fourth are kind of together, always positive. So the last sign is always positive. If that doesn't help you, if that confuses you, just forget it. All right, you don't need to know it, but that's how I remember it. All right, that helps me keep things straight, helps me keep things in order. All right, so we're going to do a couple of problems. That's basically it, right? Once you know the formulas, you're just going to plug things in. So let's look at this very first one. It says x cubed minus 16. All right. So the first thing we need to do is to determine, are these cubes or are they squares? All right. And just by looking at it, we can tell that these either are cubes or nothing, because that says x cubed. And then if we look at our chart of cubes, we'll see that 216 is there. Okay. So this problem right here, x cubed minus 216, is exactly like this. All right. So what I like to do is I like to label them. So I'm going to say a cubed is the same as x cubed, right? Just based on my problem. X cubed is in the same place as a cubed. And then 216 equals b cubed. All right, a cubed is x cubed, right? It's in the same spot. And b cubed is 216. All right. Now, for my equation, I need to know what a and b are. All right, so I need to know what just a is and just b is. So basically, I need to get rid of that cube. Okay, so to get rid of a cube, all right, if we were getting rid of a square, we would square root it. We're going to do the same thing, but we call this a cube root. So I am going to cube root both sides. All right, if I did that, the cube root and the cube would cancel out, and I would just be left with a. The same thing is going to happen over here. The cube root and the cube would cancel, and I would just be left with a equals x. Okay, so now I know that wherever I see an a in this formula up here, I'm going to put x in its spot. Okay, I'm going to do the same thing with this. I have to get rid of that cube, so I'm going to cube root it. This is where your calculator will come in handy. If you did the cube root of 216 in your calculator, you would get 6. So that means 6 equals b. So now I know what a and b are, right? A is x, b is 6. I just plug them into this equation right here, okay, where they belong. So if I did that, if I plugged them in, it would give me, parenthesis, the first one says a minus b. Well, a is x, b is 6, so x minus 6. Then it says a squared. Well, I already know a is x, so that becomes x squared plus a times b. So plus a times b would be 6x. And then it's plus b squared, since b is 6, so plus 6 squared. 6 squared is the same as 36, right? So I could write 36 in that spot. And we are finished. We factored it. Right, so once you figure out what a and b are, it's all about just plugging those numbers in. Okay, you just plug them in wherever they might go. All right, now they might get a little bit harder because we might put a number in front of them. Okay, such as let's do number 3 right here. Okay, so 125 x cubed. So you first have to see are these cubes or squares. If we go up to our squares, 125 doesn't appear anywhere, right? So it's not a square, but 125 appears on the cubes right there, right? So 125 is a perfect cube. Does 27 appear? And yes, it does. So both of these are cubes. So that means that a cubed is 125x cubed, and that means b cubed is 27. And I need to figure out, so again, it looks just like this. So I need to figure out just what a and b are. All right? So if I were doing that, I need to get rid of the cube. So I am going to cube root both sides. That way the cube root and the cube will cancel. And I'm just left with a equals. And then on the right side, the cube root of 125. If you put that in your calculator, okay, the cube root of 125 is 5, because 5 times 5 times 5 is 125. And then this cube, x cubed, and that cube root cancel each other out, so it's just 5x. So I now know that a is 5x. I'm going to do the exact same thing over here. So I'm going to take the cube root of b cubed and the cube root of 27. These cancel again, so I'm just left with b. And the cube root of 27 is 3, because 3 times 3 times 3 is 27. So now I know what a and b are, right? I'm just going to make sure I pick the right one. There's a plus sign in the middle, so now I'm going to do this top equation, right? And I'm just going to plug them in wherever they go. So this says a plus b is first. A plus b. A is 5x, b is 3. So 5x plus 3. Then it says a squared. Well, if a is 5x and I squared it, 5x times 5x is 25x squared. The middle says minus a times b. So minus a times b. 3 times 5x is 15x. And then the last one says plus b squared. Well, if b is 3 and I squared it, I would get 9. That is our final answer. Okay, so find out, are they cubes? Are they squares? Are they neither? Right? It doesn't have to be one of them. It might not be. Okay? It may not be one of them, but that's what we have to figure out. Okay? Cubes or squares? All right. Okay, there's one other thing we are going to talk about. Okay, one other thing that we are going to talk about. So you're going to see a problem that looks like this. So if you remember 2x squared plus y to the cube all squared, right? Remember what a square does. A square means I could write that thing twice. 2x squared plus y cubed, 2x squared plus y cubed, right? So I could write them 2 times, all right? And then whenever you are multiplying something that's squared, there's another formula that you can use. I'm not going to lie, I never remember this formula, right? I always seem to forget it, okay? But even if you forget it, you can still multiply these out, all right? This is what we talked about in the last section in 3.2. Whenever something is squared, you are simply going to write it twice and then just distribute, right? Just like what we did in section 3.2. So do 3x times both of them. So 3x times 3x is 9x squared. 3x times negative 5 is negative 15x. And then we're going to do it again with the negative 5. Distribute again. So negative 5 times 3x is negative 15x. Negative 5 times negative 5 is 25. And if you've done this right, in this kind of problem, if you've done it right, these two things in the middle, you should be able to combine. Okay, so if everything has worked out and you've done it correctly, you should be able to combine them. And if we did that, the 9x squared is going to stay the same. Negative 15 minus 15 is negative 30x. And then the plus 25 stays exactly the same. That would be our answer. Okay, so once you know kind of the process, right, you do the same exact thing, just distribute. All right, so that is section 3.3, right? Remember these formulas. These are what you will need to solve it. Okay, remember those formulas. All right, if you have any questions, please reach out to me, let me know. All right, I will be more than happy to help. Thank you all.